Hello everybody and welcome back to Research Methods, Section 2, where we're going to talk all about generating research questions, and then we're going to talk all about ethics, okay? Now, for the first part, generating research questions. What questions should you try and answer as part of a scientific pursuit? What research should you do? What should the goals of that research be? Well, there's lots of different places to get ideas and questions and things like that. But generally, people start with an area, right? And what area you're interested in, that can come from a lot of different sources, right? Personal preference. My particular focus area for my research is cybercrime and digital forensics. And that area kind of became my focus area because my father worked for IBM for a gazillion years, since before I was born until just a few years ago when he retired. So I always had computers around, and computer crime just kind of naturally interested me when I got into the field of criminal justice, because I noticed not a lot of the people around me at my particular university were doing that. There's also academic advantage, right? Every field, but especially criminal justice, goes through kind of phases about what's kind of the hot new topic, right? So, in the 70s and 80s, it was drugs. In the 90s, it was gangs. After 2001, it was terrorism. That was the big thing. And I think, luckily for me, that criminal justice is kind of becoming a little bit more focused on cybercrime as the 21st century moves on. And focusing in those areas gives you an advantage because it's kind of more in demand from journals and from other researchers. And along with that comes funding, right? You can get paid to do this research. It's not a lot of money, but it's not going to you, it's going to the research itself, because research has a lot of financial costs, especially depending on the size and scope of that research. So what is out there available for funding, right? You might want to look at, I think it's just grants.gov. That is where you can find a huge list of federal government grants that are available for you to apply for, or for other researchers to apply for, in order to answer some specific question or some specific focus area. It might say, hey, we have a grant of $1 million ready to give to somebody who wants to research how to reduce HIV infection in young men, something like that. Or it could be applied, i.e., some organization or group or government agency has a question, a very specific question they want answered, and they're looking for a researcher to hire to do it, right? So when I was in grad school, the local police department kind of hired the graduate students to do this applied research about how they can reduce noise complaints in a specific neighborhood in this college town, right? So how you kind of develop and figure out what general topic area interests you is really up to you, and it's going to be different for everybody. But at that point, start asking questions. Start looking at what's still not known, right? Here's what we know about that topic area. What's not yet known? What has nobody quite done the research on? Or maybe there's a lack of research in this area. And reading previously published research is a really good source for that, because they will explicitly state, like, hey, somebody else should come along and do this other thing because it's unclear how this research applies to that possible future research. So you can get a lot of good ideas for specific questions if you read previously published research in your topic area. And once you've got a general question, does learning theory apply equally to digital piracy as it does to smoking marijuana, right? Now we've got a pretty good starting point for a question. But now we have to refine that question. We have to figure out exactly what that question means. We're going to talk a lot more about that in the next section. But for now, just know that you really have to aim for specificity. That's a really difficult word to say. Specificity. We want a specific question that's not vague, right? So you don't want to just say something like, does X thing cause crime? Right? Because crime is a really broad thing, right? We want to know, the vast majority of the time, your idea, your question isn't really whether that X thing causes crime, it's whether it causes some specific type of crime or some subset of crime, right? Like violent crime or intimate partner violence or property crime or, shoplifting and robberies, that kind of thing. You don't really mean all crime, right? So we have to get more specific, more concrete, because remember, we're going to have to define every term we're going to use, and that's quite a difficult process. So the more specific you can be at this stage, the easier time you're going to have, usually, with the defining process later on. Once you've got a specific question that you're happy with, now you kind of have to evaluate it. Is this possible? Do I have the time? Do I have the energy? Do I have the money? Do I have the whatever resources I'm going to need to get this question really answered satisfactorily using the scientific method in a way that's going to result in it getting attention and peer review and all those things? And has anybody done this before? And notice that's not necessarily a deal breaker, right? There's a lot to be said about replicating research, doing essentially the same research or very similar research a few times. But if it's been done to death, is there really, are we really adding anything by doing this again? The answer might be yes, but it's often no, right? So we need to find something new and different, something that hasn't been researched before in a lot of cases. Now, research is almost always, or should be almost always, guided by theory. Okay? And theory is, every field has their own theories. And theories, contrary to how we use that word in kind of normal everyday English, doesn't just mean idea, right? If you're just talking with your friends and you use the word theory, what you really mean is idea or guess, right? But in science, a theory is something much, much different and much, in my opinion, bigger and stronger and more important. A scientific theory is a commonly accepted explanation for something that is observed, right? And there's lots of different famous theories in science. There's the theory of gravity. There's the theory of relativity that Einstein came up with. There's the theory of evolution. There's, all kinds of different theories that I'm sure the vast majority of you, if not all of you, have definitely heard of. One of the things that I kind of run into a lot is people thinking, oh, when a theory is proved, it becomes a law. No, that's not how it works. Laws and theories are completely different, and one doesn't become the other, right? A law is essentially an observation. A theory is an explanation. And both of them have been backed up by research and are commonly accepted and have all kinds of kind of paperwork behind whether they work or not, right? Now, in fields like physics and mathematics, theories are a lot kind of easier to prove because there's not the human element. In social science, theories become much more difficult just because humans are weird and complicated and often very irrational. And so we get a heck of a lot of random error that the more hard sciences don't have to deal with, or at least don't have to deal with as much. Now, theory is very important because theory is what kind of becomes the basis for our hypothesis and our, why we're asking our questions and how we test them in certain ways and how we measure them in certain ways. In criminal justice, we've developed a bunch of theories that all have at least some measure of pretty good research to support them, right? And if you want to know more about these, you can take my criminology course. But there's things like learning theory and social control theory and strain theory and all these other lovely, fanciful theories about why people commit crime and how crimes happen and all these things. But importantly, any scientific theory has to be falsifiable. Okay? And that big fancy word just means it has to be possible to prove it wrong. Because that's really what science is. Science isn't about people proving things true or proving things correct. Science is much more about people proving things wrong. People will propose something, and then a bunch of experiments will happen, a bunch of research will get done trying to prove it wrong. We want to prove ideas are false. And if every researcher throws their best research at an idea and they fail to prove it wrong, then it becomes generally accepted, right? So science isn't about proving anything right. It's about scientists trying their best to prove some idea or theory or whatever wrong. And if they can't, that's when it gets accepted. Now, so if it's not falsifiable, if it's not possible to prove wrong, then it's not scientific. That's just how it works, right? So something like, there's a tiny purple teacup orbiting the star Alpha Centauri. Now, is it possible for us to prove that wrong? No, at least not with today's technology. Maybe a few hundred years from now it would be possible to prove that wrong. But we can't possibly prove it wrong now, okay? So we need some kind of theory to back up whatever kind of research or experiment we're going to do. So, as an example, I think it was Minneapolis, but don't quote me on that. They wanted to do an experiment about, like the city government wanted to do an experiment where they had a mandatory arrest policy for domestic abusers. So if the police arrive at your house and your spouse or significant other, roommate, whatever, has visible signs of injury, the police are legally required at that point to arrest the other person, the person without the injuries, right? So guided by theory, what would that do to the incidence of domestic violence? Well, according to deterrence theory, that guaranteed arrest would both have a general deterrent effect and it would have a specific deterrent effect on those people who are arrested, and thus they would be much less likely to recidivate. On the other hand, something like labeling theory would predict that domestic violence would go up after people have been arrested for it because now they've been labeled as a domestic abuser. So theory is going to guide kind of what we expect in all these different instances, all right? So again, here's just kind of the basic process. We develop our question, then we learn more about it. We go into the existing research, we go into the existing literature that's out there, we read all we can find, we take kind of suggestions from the authors of those papers, we use that to kind of guide our future research. This process is called the literature review process. And we learn everything we can about what's already been done and the problems they had, which might help us prevent those same problems in our research, things like that. Then we sit down and we design our research. We figure out what we're going to do. Here's how we're going to answer our questions. Are we going to use a survey? Are we going to use an interview? Are we going to use a true experiment or a quasi-experiment? Whatever. Then we actually perform the data collection. If it's an experiment, we perform the experiment. If it's a survey, we send out the survey and start collecting back, hopefully a lot of them. Once we get all that data back, we do our analysis, where we figure out what that data we gathered really says, and we do a bunch of statistics and number crunching and computer work, and then finally reporting. We write it up, we submit it to a journal, we present it at a conference, etc., etc. So that's the general idea for the process. Another way of looking at that is what's called the research circle. Okay, and this is using some terms that we haven't quite discussed yet, but we will. So we start kind of in the upper left there of this fun image here with an observation, right? We see something happening. We notice that, oh, wow, it looks like crime is rising, whatever. Now that leads us to a question. Why is crime rising? Is crime rising because the local government just passed a law, whatever? Hypothesis. The hypothesis is kind of the predicted relationship between your variables, right? So a hypothesis is, I believe as this increases, this other thing decreases, right? We make a prediction, we do our experiment, we gather our data, we see results, and that results either supports our idea or we have to reject our idea because the data didn't show that we were correct. And either way, we just keep going around and around and around and around, and everything kind of, it never really stops. It just constantly gets refined, constantly gets expanded, constantly gets modified a little bit, okay? But some of the terms you're going to have to know for this semester and from here on out with any kind of research you're doing, okay? We're going to start by talking about the independent and dependent variables, okay? These are the things you think affect each other. There are lots of different ways to think about independent variables and dependent variables and remember them straight in your head, because it took me a few years to get them straight in my head. But the independent variable, also called the X variable or the causal variable, that's the thing that is being manipulated. That's kind of the input, right? So it might be a new drug for Parkinson's disease. It might be a new law to curb gun violence. It might be job training for prisoners, whatever. Then the dependent variable is the outcome. That's the thing you're trying to affect, right? It's also called the Y variable. The dependent variable is the one that you think changing the independent variable will affect. So this new law designed to reduce computer crime is the independent variable, and the actual measured amount of computer crime is the dependent variable, right? You can have more than one independent variable very easily, right? So my dissertation research was about the demographics of computer criminals. Do they demographically look like other criminals? So I had 4 independent variables. It was age, race, gender, and education, right? And then the dependent variable was essentially, are you in prison for committing computer crime or not, right? Having more than one dependent variable becomes a little trickier statistically. You kind of have to do them separately, but it is possible if you're willing to put in the work. The hypothesis, as I said earlier when describing this picture, is that kind of your predicted relationship between those variables. So I predicted that as age increases, your likelihood to be in prison for a computer crime decreases, right? That was my hypothesis. The null hypothesis is the actual thing we're testing, and we're seeing whether that could possibly be true. Because again, science isn't about proving people right, it's about proving people wrong. This is one more example of that. We're going to test the null hypothesis and see if it's possible to reject that. And if we do reject the null hypothesis, i.e. there is no relationship between those variables, then we know that our hypothesis was probably, hopefully, correct, right? Now, importantly, when talking about variables have to vary, right? If they don't vary, if they don't have different values, then they're what's called a constant, right? So if I do a survey right now and every person is asked, are you a human being, yes or no? Well, assuming everybody answers truthfully, everybody's going to answer yes. So literally 100% of my responses are going to have the same value for that variable, meaning it's not a variable, it's a constant, right? So you have to be careful not to include constants in your research question. And you'd be amazed at how often students do this. I've had students in my class where they want to know whether rehabilitation programs in prisons reduce recidivism. And then 100% of their sample participates in this rehabilitation program in their research design, and then they gauge recidivism afterward. Well, in that case, your independent variable isn't a variable. Everybody in your sample, everybody you're studying has been through this rehabilitation program, and thus that independent variable is a constant, right? You have to have somebody to compare them to. That independent variable has to actually vary. So if your independent variable was successfully completing this rehabilitation program in a prison, you have to have members of your study that can answer no to that, right? When looking at the relationship between variables, there are positive relationships and negative relationships. And this has nothing to do with any kind of moral judgment or good or bad. This is merely direction, right? So a positive relationship means as the independent variable increases, the dependent variable increases, right? So a rise in X causes a rise in Y. A negative relationship is the opposite. An increase in X causes a decrease in Y. Or a decrease in X causes an increase in Y, right? So this is a negative relationship. This, where they rise and fall together, is a positive relationship, right? Now, as I used this term in the previous slide, but in case you didn't know what it means, replication means doing essentially the same thing that a previous researcher did again for some reason. And lots of times there are plenty of good reasons to replicate studies. We want to not just do some important, highly impactful study once. We want to make sure it works in other areas, in other times, in other situations with different sample and a different population and all those things. Because there are such a thing as, serendipitous or anomalous findings, right? The way statistics works, and we're not gonna get too deep into math in this class, I promise. But the way statistics works, 1 out of every 20 times that you find some statistical relationship, that's going to be due to pure chance. On average, 1 out of every 20 statistically significant relationship is just not significant, right? Because we have this whole 95% confidence thing. You'll learn more about it in a statistics course, I promise. But there is such a thing as studies that show something that just isn't true. They happen to find this relationship just by pure random chance, not because there's actually a relationship in the real world. And that's one of the reasons why replication is so important, right? All right, so the last thing we're going to talk about in this subsection is about generalizability. And generalizability is just kind of a big fancy word for how much does that apply to other people? What about other situations? We found that there's a relationship between the independent variable and the dependent variable using these 300 people, but how much of the conclusions we can draw from those 300 people actually apply to others, right? And we're going to talk more about sampling later on, but think about it like this. If I do a poll for voters in the state of Texas, who are you going to vote for in the upcoming presidential election? And I randomly select 1,200 registered voters in the state of Texas. Now, we ask those 1,200 voters, who are you going to vote for? Now we need to know the generalizability in 2 different ways. Number 1, how well does this random sample of 1,200 registered voters in the state of Texas, what does that tell us about all of the registered voters in the state of Texas? So how well does our sample generalize to our population? And then also, how well does that translate to other populations, right? Which, if you remember from the last section, that's external validity. How well do our conclusions translate to other people's, places, and times? So we might have really good sample to population generalizability, and our 1,200 registered voters and who they say they're going to vote for could give us a really accurate prediction about who's going to vote for which candidate in this upcoming presidential election. But at the same time, that's not going to give us a good generalizability for other states or, the next presidential election after that, right? So that generalizability there's these two different parts to it, and just because one is really good and really high doesn't necessarily mean the other is. And they're both important for very different reasons. All right, we're going to go ahead and take a break there. Thank you so much for watching. We'll be back in just a minute.